The experiment I'm standing next to is, as Marc has said, it's the reference crop. We have two reference crops this year, one on the light textured soil and one on the heavy textured soil. And it's probably important to understand why we did it this year. So those of you with a long memory may be able to cast them back to 1993 when David Furman set up the first reference crop. And in that one we had Estimer and Cara, so a very determinate variety, a very indeterminate variety, different stocks, and we looked at the yield and performance of those crops in different years for crops grown in very similar ways. In 2006 the experiment evolved a bit. We still had Estimer and Cara, but we introduced irrigation treatments, so we had rain-fed or irrigated, and we also introduced nitrogen treatments. And that series of experiments carried on up to 2019. And what we showed in those experiments, and for those of you who went to the AGM, you remember Sarah's presentation on this, we showed that on average the nitrogen requirement for Estimer was about twice that of Cara. To get the optimum yield, you need to apply about twice the amount of nitrogen. The elephant in the room was, if you actually looked at the variation in yields from year to year and the variation in the optimum nitrogen requirements of those crops from year to year, there was a huge variation. And that's something we didn't really understand. So this year we've set up a further evolution of the reference crop, where first of all we're starting to phase out some of the older varieties. So Cara has been dropped, Estimer's still there, but we've introduced Royal, Innovator, and we have a plot of Russet Burbank, which we'll come on to a little bit later. And what we're interested in here is, by growing these varieties, again with different nitrogen rates, on two different areas of the field, very different soil textures, can we start to unravel why we have this huge variation in yield and nitrogen requirement from season to season. There's a slide showing soil mineral nitrogen. And first of all, we've measured it in the light area and also in the heavy area behind me. And essentially we've got somewhere between perhaps 45, 55 kilograms of nitrogen per hectare in those areas. And that's very similar to what we found on average in previous seasons. There is another slide that shows historic data from about 2010 to 2019, where we've plotted the amount of soil mineral nitrogen versus the optimum nitrogen requirement for an irrigated crop of Estimer. And if you look, there's quite a big range in soil mineral nitrogen, there's quite a big range in the optimum N requirement. But the point there is there's no relationship between the two. In other words, you can't take a measurement of soil mineral nitrogen and from that calculate how much nitrogen your crop is going to need. And that's confirms what you found previously, and again there's a little graph that shows that from historic data. And the other part of this presentation also shows that once you apply the nitrogen, the correct amount of nitrogen for the optimum yield still varies. And again, we have some ideas why that may happen, but we've no sort of certainty. And again, this is what we're trying to study in these two experiments. So the final thing is that by looking at soil mineral nitrogen, soil textures, different levels of soil damage, this starts to link in with some of the work we're doing in the soil AHDB rotations project, which is what I'm planning to talk about next. Okay, we're just standing at the moment next to the plot of Russet Burbank on the light textured soil. This Russet Burbank crop has been given 190 kilograms of N per hectare, and in a minute we're going to walk up to the same crop of Russet Burbank given the same amount of nitrogen on the heavy end of the field, and again hopefully you can see some of the differences in the growth habit. So essentially what we're doing here is several things. First of all, we could compare the same variety given the same amount of nitrogen on two different areas of the field. And furthermore, and I think this is probably where it gets quite interesting, or even more interesting, is we're going to be comparing Russet Burbank crops grown at Cambridge with Russet Burbank crops grown in Washington State. So that was the plan. Due to COVID, that has been scrapped for this year at least, but the intention is in 2021 that will carry on. And ideally what we want to show is not what the yield is of Russet Burbank at Cambridge or in Washington State, but how well they achieved their potential yield. So obviously the potential in Washington State is higher than it is at Cambridge. In other words, they should get a high yield. Do they always achieve that high yield and fulfill their bigger potential? So that's one of the things we'll be looking at. And again, they'll be monitoring their crops in a very similar way to we're monitoring the crops here. So looking at emergence, looking at ground cover development, and looking at radiation use as well.
Fine, doing very well. Rates of different varieties. You do 2 rates for each variety.
No, we've got
Because this would make a. Remember that nice naturalis one you did? Oh, it'd be really nice photos of this.
We've now moved up to the heavy part of the field, so this is about 18% clay content compared with 12 at the lighter end, or where the reference crop is. And the consequence of the different change in texture was this crop emerged about 8 days after the crop on the light textured part of the field, even though planted on the same day. And as you can see, the ground cover is significantly behind the same russet Burbank crop we saw a bit earlier. No, I did have a